Heating a metal rod to red hot up to its melting point might not seem like an easy task, but for an induction heater it's just as simple as cutting a piece of cake. Induction heating refers to the process of heating an electrically conducting object that is usually a metal by electromagnetic induction through heat generated in the object by eddy currents. Well, this is Saman here from DIY King, and in today's video I'm going to show you how an induction heater works and what are the basic principles behind its working. Moreover, we are also going to build an induction heater that can handle surges of up to 300 watts. And it looks like a professional kit that are available from eBay and Amazon and works like one. So have a look at how powerful this induction heater is. An induction heater consists of an electromagnet and an electronic oscillator that passes a high-frequency alternating current through the electromagnet and thus inducing large eddy currents into our subject, causing it to heat up real quick. So I started with the schematic. The overall layout of this oscillator is simple. The object here is to convert the direct current to a high-frequency alternating current, for which we are going to use LC oscillator that switches the MOSFET at a high frequency of nearly 20 kHz for the heating to be most effective. Now, instead of building the circuit on a perf board, I rather decided to get it done on PCBs. So I visited the website called jlcpcb.com. They have such a nice website on which you can get instant quotes for your PCBs. All you need to do is to upload your Gerber files, and once these files are uploaded, you can verify them by the built-in Gerber viewers, which is a nice tool to have. Later on, you need to check out the options that are given below, and once you are done with that, you can just check out with your order. For the first order, you can get as low as $2 on 10 PCBs along with free shipment to your doorstep. So as I've ordered mine, I just received the parcel in just a week, and the quality is just way too good for the prices they are offering. So don't forget to check out their website. The schematic, Gerber files and the list of the required material for the project will be available on Instructables. Now it's the time to solder all the components onto the PCB. Now for the switching, I am going to use IRF 540 MOSFETs. I started by attaching the aluminum heat sinks to ensure heat dissipation and to make sure that larger amounts of current are handled easily, I decided to use them in pairs for each channel. The capacitors that I'm going to use for this circuit are VIMA non-polar capacitors that are rated at 400 volt AC and 0.33 microfarad. Now both of them are soldered in parallel in order to have a capacity of nearly 0.66 microfarad. The inductors are made using some old ferrite cores that I found from old computer scrap and winding them using 1.2 mm insulated copper wire. I have given 30 turns, which is subjected to produce an induction of nearly 100 microhenry. Later, the insulation from both ends were removed and the end results were pretty nice. Now to mount the induction coil to the PCB, I'm going to use some pins that I've got from an XT60 connector to ensure that the main coil is mounted firmly to the PCB. I just cut out a pair of hatches onto the PCB using an angle grinder. Later, by using some silver coated copper wire, I ensured that both the connectors were soldered properly onto the PCB. The induction coil for this heater is made out of 5 mm diameter copper pipe that is usually used in refrigerator compressors. I've wound the coil using a cardboard roll measuring nearly an inch in diameter, and I have given 8 turns in total. Here I'm using a 12 volt DC cooling fan that I've got from an old graphics card in order to cool down the MOSFETs. Since later I'm going to power this whole induction heater by using a 15 volt DC supply, so I'm using a 10 ohm resistor in order to drop the voltage down to 12 volt for the fan to operate properly. Since initially I was using capacitors that are rated at 400 volts, so they swelled up at the first run as the output peaks were larger than that. So I have replaced them with the larger ones that are rated at 1000 volts, and they seem to work flawlessly. To power this induction heater, I'm going to use a server power supply that is rated at 15 volt and can supply currents of up to 130 ampere. just to be on safer side. Moreover, the results produced by this induction heater are outstanding.
So guys, if you like this video, then don't forget to give it a big thumbs up. Moreover, have a look at some of my other videos as well. And for more upcoming exciting projects, do subscribe to my YouTube channel by clicking on the link just given over here. Thank you very much for watching this video, and I'll see you soon in the next one.